All right, welcome back everybody. So in our previous lecture, we saw how to summarize an IPv4 address. So two examples. So these numbers you see up here are these networks summarized. This is the summary address for these networks. This is the summary address for these networks. And this is the summary address for these networks. You can go ahead and calculate yourself with the one, following the video that I showed you previously. Now what I did is that each and every port, it's its own VLAN. If you were to go inside these switches and just do a show VLAN brief, you would see that each VLAN is assigned to a particular port, creating different networks, right? That's why you see them here. And it's the same thing going all the way across. One of the things that I like to do in my lab is I try to make it simple in the sense of you don't have to remember weird IP addresses. Well, this is the 192.168.23.89, something like that. No. I try to make it contiguous. I try to make them simple. I use the same types of interfaces, like the switches are all ports 24. Where they go connected to the router is the F00. Obviously, when you go to the router, this is going to be a router on a stick situation. Show IP int brief. All right, so you see that's for VLAN 14, VLAN 15, 16, and 17. Is that a requirement? No, it's not. It's something you do for visualization purposes, so you understand. Oh, that's for VLAN 14. If you were to do a show start, small configuration, you will see that subinterface 14 is for the incap.1q14, which is for the 104 network. So I try to make things as easy as possible as far as the subnetting is concerned, which we're not subnetting here at all. So you don't have to be concerned with that. And even here, you see 10.1.4, 10.1.8, 10.1.12. It's a contiguous type of network. All right, so it's not something that you need to memorize. You can see that all the routers that are connecting to the core router are S001, whereas these are our distribution routers. These are, let's just call this our distribution layer. This is our access layer, and this would be the core. So, and we are running EIGRP 100 on here. If you were to look at the routing tables, look at the core actually, because that's where our focus is going to be at. Now, in the scheme of things, this is not a big network, obviously. Show IP route. You see that we're using, no, that's not good. Why I'm not seeing the others. Right here, show IP in brief, show IP, oops. Show IP int brief. 10.1.16 is up, 10.1.10. Let's see if we can ping their counterparts. Ping. 10.1.1.5, yay, and then 10 would be 9, and then 14 would be 13. So we can ping that, show IP route. I should be getting a lot more networks than that, 108, because 108 stops, well, it's giving me the summary. Why is it giving me the summary? It shouldn't be giving me the summary. It should be giving me, because I did take out the summary from here. Let's see. I'm trying to fix it so you guys can see what I'm talking about. You show start. Ah, there it is. So I'm going to interface S0/0/1. I'm going to say no. Take this out of the equation. You see I'm not selecting that last number. There you go. Do WR. And close this back up again. Let's fast forward through time. The packet tracer. Let's go back into the core router. New adjacencies. Also, show IP route. There we go. Now you see that EIGRP is giving us every last single VLAN that exists at the access layer. Obviously, in the scheme of things, in the global internet routing tables, this is not even a fraction of what's there. But for our purposes, in the lab, understanding it's just not about calculating summary addresses, about why are we using it and how we would do it. So our job, our mission, if we choose to accept it, is to minimize the amount of route entries, because here this core router, if I'm in the 100, 101, 102, 103, those 4 networks there, I need to, if I want to go to, let's say the 107, I need to go through 100. The router literally needs to look at from 100 all the way to finally it reaches to 107 and then makes a decision, hey, this is where I need to send you out by. This router does not need to see every last little entry that exists underneath the distribution layer, right? Doesn't need to see every VLAN that exists. Just to know a summary. So what do? We summarize from right here. So let's come. This is the summary address right here. Then I'm going to move this over here, and I'm going to place the router right where it's at. Open it up nice and wide. Let's bring it up to here. I think that should be enough where you can see it nice and clear. Enable, conti. They're all going to be int s0/0/1. All right, so we go inside the interface and do IP summary. You see I told you I forgot the hyphen. IP summary address, we put the routing protocol, which is EIGRP. The autonomous system is 100. All right. And then the summary address is 192.168.100.0 with a dotted decimal mask of 255.255.252.0. If this will be wrong, it will give me an error. Now do WR. Now, one of the things that I need you to pay attention to is a number that just mysteriously appears by itself. Show start. This number right here. What is that number? That is the default administrative distance of a summary route. Can you put your own? Yes. You want, though, this to take effect. You want this line, this syntax that we just typed. You want the router to pay attention to that, not the global routing table, EIGRP, which is 90. You want it to pay attention to that summary address. So that's why that default administrative distance of 5, less than 90, so that can take effect and send that information up to the core router. That's what that's there. Can you make your own? Yes. Why would you want to do that? Unless you have to, but you can. You can. But that's what that number is. I didn't put it there. It went there automatically if you don't choose to pick one yourself. Let's move the lab over to the right. All right, so let's open this up so you can see it nice and clear. Control C, conf T, interface S0/0/1, all the same. IP summary address, EIGRP 100. Okay, this is going to be 192.168.104.0, 255.255.252.0, DWR. All right, and then same thing. Same thing, you're going to see, I'm not going to bore you to death with that. Move this over here. This is a 108. And we had it before, but we took it out so you can see what happens. I'm going to go, I'm inside, but again, I don't trust myself. Int S0/0/1. I just want to make sure I'm in the right interface. All right, I'm going to say IP summary address, EIGRP 100. And there's going to be 192.168.108.0, 255.255.252.0, DWR. All right, so you saw that we created new adjacencies. So now we go back up to the router up here, the core router. Let's maximize it. And then we're going to do show IP route. Now we have the summary routes. This is a more efficient routing table. So if you're in the 100.0/22 network, anywhere in there, and you want to get to, let's say, that 107 network, now it'll make, okay, we got the 100, oh, the 104. So it can make a quicker decision. It doesn't have to look at this laundry list of entries in the routing table. Now it just looks at the summary addresses. This is the reason we summarize. This is what Cisco's authors are telling us that we're not doing. And this is the justification, or one of the justifications, for creating lists. Okay? Where we have the MRs, the MSs, the RLOCs, the EIDs, the egress TRX, and the ITRX, and all this crazy stuff that's going on in the SD-WAN fabric enterprise. Okay? That we need to create now. or if you want. I mean, that's up to you if you want to do SD-WAN. It's always a business decision. So, but anyway, route summarization is important. The routing tables in the internet are huge. And that's because of everything that's been going on, that everybody's online. Kids are more kids are online more of the time. Adults are working from home. All these different things. ISPs were not ready to handle this capacity, so they're trying to catch up. And just for the simple fact that we're using IPv4 to do everything instead of using IPv6. But before we can do IPv6, the software needs to catch up. ISPs need to catch up, so we can finally maybe use instead of using a combination of DNS 64 and 464 XLAT, something like that. But until then, we're stuck with this. All right, we may not see it in our lifetime. I don't know, in my lifetime anyway. We may not see it, but we shall see. And run ISIS on top of that. But I digress. This is what summarization is all about: reducing the summary addresses. Now, in this next lab that we're going to do is in BGP. It's going to be in GNS3. All right, but I'll talk about it there. It's going to be summarization, but the syntax is going to be a little bit different. And I'll elaborate once we get there. All right, so I'll see you in the next one.